Hey everyone, and welcome back. This is class 4. We're going to be talking about even and odd functions today. So we're going to try and establish whether a function is even, odd, or neither. Those are going to be the three criteria we're going to look for in our functions. Essential questions for today: how can you tell? So is it even, is it odd, is it neither? And then is it possible for it to be both? Can it be even and odd? So by the end of today, you should be able to answer those questions. So for last video, just a quick recap, we did transformations, and this was one of our more important videos. So again, watch it back again, make sure that you have got it. You've learned that parent functions for the different types of functions, and you know the parameters for doing the transformation, so that y equals a times the function, and then inside the function you have 1 over b parenthesis x minus h, close it all, plus k. So being able to change a, b, h, and k to transform the function, we need to know that equation and then what each of those letters do if we do change those. All right, so we're going to start off talking about function symmetry and why we care about that. So when you are talking about doing even, odd, neither functions, like it's one of those things that like you're going to ask yourself, well, why do I care? Like, who cares whether it's even or odd? And the reason is that we, in the math world, we're always looking for patterns. And if these functions are representing something in the real world, identifying these patterns can help with making predictions, getting better data, writing code, and so on. So just identifying these things is going to be important. And today is about identifying if there is symmetry in the function. So is it just this kind of asymmetrical function that there isn't really much else going on, or is there a symmetry that we can use? So from geometry, what are the different types of symmetries? So we had axial symmetry, so lines of symmetry, and we had rotational symmetries. And one that we didn't really, like, I guess, call out by name as much is a point symmetry. So that is if you reflect an object through a point instead of over a line, that it would end up symmetrical with its image. And it's the same as rotating the shape 180 degrees through a center point, like in the center of the shape. So it does have like a rotational symmetry as well. But point symmetry is one that we didn't really talk about too much, and we're going to mention it a little bit today. So if we just take a square or any regular polygon, this will pretty much work with. Axial symmetry, so these are how many lines of symmetry did it have? Like we knew that there was 4. So any regular shape, there's the same number of lines of symmetry as there is sides. So the vertical, the horizontal, and then the 2 diagonals. So if I reflect over any of those lines, the shape will reflect onto itself. That's what makes it a symmetry. Rotational symmetry, if I rotate it 90 degrees around that center point, it will rotate onto itself. So that was kind of the key idea. The last one is point symmetry. So this would be where every point on the shape goes back towards a center point. So it's kind of like the center rotation, but it's a point symmetry. So it would be a point of symmetry. So like this point would go towards here, reflect out the same distance on the other side. Same thing with all of these. So all points move towards the center and then back out again, and you end up with the exact same shape. So point symmetry in this case. And you imagine if I rotated this 180 degrees, this point would end up on here, that point would end up back there, and the corners would flip basically. It's the same thing that just happened with a point symmetry. So if we were tracing out where these things ended up, D is going to reflect through the point, and we'll call this S, so point of symmetry. So D reflects through S, ends up at B, B ends up at D, A reflects through, ends up at C, C reflects through, ends up at A. You get the same result if you rotate 180 degrees. That's kind of the key part. So even, odd, neither. This is what our focus is going to be today. So it's a type of symmetry. So we have even functions that are symmetrical in a certain way, odd, same thing, neither, they are not symmetrical. So even functions, and this is going to be mostly notes, so make sure you're getting this down. Even functions are symmetrical over the y-axis. So emphasis, it has to be over the y-axis. It's not just that they're symmetrical over a vertical line, it's they're symmetrical over the y-axis. So we can get them to sit on the y-axis sometimes if we need to become an even function, but if they are not symmetrical over the y-axis in their current format, they are not an even function. So that just means that if you reflect it over the y-axis, the pre-image and the image will map onto each other. So it'll look the exact same. In terms of function notation, how do we reflect a function over the y-axis? We do f of negative x. So in terms of functions, if f of x is the same as f of negative x, so that's the reflection, then it is an even function. Next up is odd functions. Now, an odd function is a point symmetry, so what we just talked about in the previous slide, through the origin, so through 0, 0. You'll also notice that, like, okay, if you could rotate the shape 180 degrees around 0, 0, you will get the same result. So that's a kind of a cheat for it. Like, if you could notice that a rotation of 180 degrees around 0, 0 would make the shape look the exact same in the before and after, then you've got an odd function. What it technically is if you reflect the original function over the x-axis and reflect the original function over the y-axis, the two reflections will be the exact same. Or if you reflect over x and then reflect over y, it reflects onto itself. Like, that would be another way of thinking about it. So there's a couple of different ways that you can make sense of this in your head. In terms of function notation, the reflection over the x-axis is that minus f of x. Reflection over the y-axis is f of negative x. So if the two of those are equal to one another, so if their two images are the same, then it is an odd function. And then neither, pretty self-descriptive. It does not fit the criteria for either even or odd. So we have even functions, odd functions, and neither. It's just going to be an adjective to classify a function. So we have an even quadratic function, we have an odd cubic function, something like that. Okay, so a little bit of math inception. We have a math video within a math video. Let's take a look at some examples. All right, so let's take a look at a couple of examples. The first one here, you can see from the function screen on the left, this is a sine function, but it has a horizontal compression by a factor of pi. And we've put a limit on the domain as well from -2 to +2. So the question we want to know is this function even, odd, or neither? So remember, if it is going to be even, it will have a reflection across the y-axis that will match up exactly with the original function. How do we do that? We do f of negative x. We're changing the x value to negative. So if I turn this one on, it does not match up exactly. So we would say, okay, this one is not an even function. If it is odd, minus f of x and f of negative x will match up with each other. So a reflection over the x-axis and a reflection of the y-axis will result in the same image. It does not have to match up with the original function though. So then we click that one and we can see that, the blue and the green are both in the same spot. So this is an odd function. So the reflection over the x-axis and the reflection over the y-axis both match up with the same image. So we'd say this is an odd function. And sine functions, cos functions are typically going to be odd functions. All right, let's take a look at another one. We have an absolute value function. It has been reflected over the x-axis and also translated up 1 unit. Is this an even, an odd, or a neither function? So take a shot in your head, see what you think. All right, if it is going to be even, if I reflect it over the y-axis, it should reflect onto itself. So that is f of negative x. Let's turn that one on. It does. So this is an even function. If I turn on the reflection over the x-axis, it does not match up with the reflection over the y-axis. So this is not an odd function. So this one is just even. Third example. We have a quadratic. It has been translated 1 unit to the right. Is this an even, odd, or neither function? So let's check the reflection on the y-axis. No, it's not. And then reflection over the x-axis, also no. So this one is a neither. Remember, our 3 options are even, odd, or neither. Now that does raise the question, can it be both even and odd? So can it do both? And is there a scenario where it will be even and odd? I want you to try and think of one. There's one that comes to mind. 1 equals x squared plus y squared. Now, if I reflect that over the x-axis, it reflects onto itself. If I reflect over the y-axis, it reflects onto itself, and both reflections together would give me the same image. So we would say, okay, this is both, right? No, because this is not a function. So if I do a vertical line test, so x equals 1, for example, or let's go a half, so it actually cuts through it. It cuts through the equation in 2 spots. So this is not a function. So we can't say it's an even or an odd or neither function because it's not a function. Can you guys think of any other example? All right, there is one that you could argue, and that is a linear function with a slope of 0 and no translation. So that would be f of 0. So basically slope of 0, no vertical translation. So you get a horizontal line on the x-axis. So if we say, all right, turn on reflection over the y-axis, it reflects onto itself. Reflection of the x-axis also reflects onto itself. So this is the only one that you could consider to be both. So keep an eye out for that. I'll probably never ask it, and you'll probably never see it in a test because it is a slightly controversial one. With the question mark of, is this technically a function or not? Does it count? But for me, it is a linear function with a slope of 0 and a y-intercept of 0. And both reflections do reflect onto itself. So this one would count in my books, but you won't see it probably on any test. All right. So if you have questions about that, obviously, shoot me over a message on Schoology so we can go through it. But pretty self-explanatory. You should be able to check a lot of these on Desmos to see, are they even, odd, or neither functions? All right, your turn. So are each of the functions even, odd, or neither? And I presented 3 different versions of a function. We have an equation, we have a table, and we have a graph. So you're going to have to try and determine which of those are functions and which ones are not. Pause the video, come back, and let me know how you did. Okay, so with the first one, f of x is a half x. And what is that going to look like? Let's take a look on a piece of graph. So it's another video within a video. Okay, the first question was, is f of x equals a half x a even, an odd, or neither type of function? So first thing you should do is take a look at it on a graph. Graph it out. Even if you're pretty sure you can visualize it, putting it on paper or on computer just gives you that visual and lets you kind of get more used to what these functions are going to look like. And then putting it through the transformations is really easy to do with something like Desmos, or break out your geometry skills. You know how to transform pictures. So especially when it's on a coordinate plane. So we know reflections. We are changing the coordinates of x, changing the coordinates of y, depending on which one we want to do. So the first one was to reflect it over the y-axis, and that will tell us if this is even or not. So reflection of the y-axis, no, it's not even. It's not reflecting onto itself. So we would say not even. If we do the reflection over the x-axis, now we go back to the original function here. They do reflect onto each other. Another way to think of this is if you reflect it over x and then reflect it over y, does it reflect onto itself? That's the other way of thinking about it. And yes, it does in this case. So if you think about that, like a reflection over x, reflection over y, that is very similar to a rotation. Actually, it's the exact same as a rotation of 180 degrees around 0, 0. So thinking too, like if I reflect over x, oh, that's going to change the y coordinate to be negative. Reflect over y, that's going to change the x coordinate to be negative. So if I change the x and the y coordinate to be negative, that's the same as a rotation of 180 degrees. You can remember that far back to geometry. Let's look at question 2. This one was the table. Now for the table, again, get it on paper, see what it looks like. So here's our points. It looks like it's a quadratic, but it's individual points, so it's not a continuous function, it is a discrete function. So bringing out some of our old vocabulary again. Continuous has the line, so you can go from beginning or one side to the other without lifting your pencil. The discrete function has breaks in it, so it is not continuous. So for this one, if we were to reflect the points over the y-axis, point on 0, 0 would stay the exact same. -1 minus 1 would map to become minus 1, or plus 1 minus 1. So they would map onto each other. And then negative 2, negative 4, and 2, negative 4 would also map onto each other. So this one is symmetrical over the y-axis. So this one is an even function. If we were to reflect over the x-axis, then we would end up here, so no, it's not. So this one is an even function. Then moving over to the last one, f of x is x cubed. So we've got a cubic function. If we reflect that over the x-axis, here's the shape we get. Sorry, I should reflect over the y-axis first. So here's the shape we get, and reflect over the x-axis. It ends up on top. Same image for both, so this one is also an odd function. Okay, let's wrap it up for today. How can I tell if a function is even, odd, or neither? So checking it out to see even function. Is it symmetrical over the y-axis? Does reflection over the y-axis map onto the original image? An odd function, can you reflect it over the x-axis and reflect over the y, and those two images end up on top of each other? Or would a rotation of 180 degrees over the point 0, 0 work, or a point symmetry through 0, 0? Neither. It does not fit either of those criteria. Is it possible for a function to be even and odd? Not really. There is that exception of when y equals 0, but it's going to be questionable whether that's going to be included or not. So you won't be asked that, but just remember, keep that in the back of your head as that's a possible exception to the rule, but in general, no. So after today, you should be able to complete Unit 1, Module 2, the even odd functions folder. Get started in that, get through all the questions, shoot me any questions if you have them.